All right, so we're going to go through Notes 2.3, which is going to cover ionic bonding. And so ionic bonding is the process that's going to occur when atoms that have formed ions will actually join together. And so ionic bond is basically the joining of a metal and a nonmetal, because if we remember, metals are going to form positive ions, where a nonmetal is going to form a negative ion. And basically what we get is we get one positive, one negative, and when we get things that are oppositely charged, they're going to be attracted to one another. So we're going to go through the process that you would get and do some examples of some different ionic bonds. So the classic example is going to be that of sodium chloride. So we're going to start with sodium, Na, and we're just going to do the Lewis dot model. So sodium has 1 valence electron. Chlorine has 7 valence electrons. If we look at the periodic table, here's sodium. Remember, sodium's in the first column, so that's how we know 1 valence electron. Chlorine is going to be over here. It's in the 7th column, so that's my 7 valence electrons. Remember, here we skip these middle transition metals. Now, remember we said atoms are going to form ions by either gaining or losing electrons. So sodium, to fill its outer shell, is going to lose this electron, and chlorine, to fill its outer shell, needs to gain an extra electron. So sodium is actually going to transfer its 1 electron over to chlorine. So let's draw this. This is actually the first step that we need to do in showing the process of ionic bonding. So we're going to show sodium transferring its electron over to chlorine. Next, then, the second step is we're going to show the transfer of electron and the new charge that is present for each atom. So sodium, because it lost that electron, now becomes a 1 positive charge. It has a 1 more proton than it does an electron. And chlorine now has 8 valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And around each element, we're going to draw these brackets, and then on the outside, we're going to list the charge that they become. So sodium became positively charged, chlorine becomes 1 negatively charged, and basically what you get is you get a positive and a negative atom, and they're going to be attracted to one another. And the third thing that they're going to do is they're going to form a new compound. And what we need to know is how to write that compound, so that's NaCl, because we have 1 chlorine and 1 sodium. We always do the metal first, so sodium is my metal, so just like they appear on the periodic table. Sodium's right here, chlorine's right here. Sodium comes first, moving from left to right. So I write sodium first, chlorine second, and the name of this is, I'm going to name this. So this is now named sodium chloride. The big difference now is we've just changed the ending of chlorine to ide, I-D-E. And you guys know this as simply salt. So sodium chloride is the official name of salt. Now, let's do a second ionic bond. Another example is going to be, we're going to do the elements magnesium, Mg, and so magnesium, looking at the periodic table, is right here. Second column has 2 valence electrons. And we'll do bromine, Br. Bromine is right here. It's just underneath chlorine. It's also in the 7th column, so it also has 7 valence electrons. So the first step is show the transfer of electrons. So what I'm going to do is magnesium needs to lose 2 to fill its outer shell. Bromine needs only 1. So I'm going to transfer 1 of those electrons over there. Now, that makes bromine happy. It has a full outer shell. Magnesium, though, is not happy. It still has an extra electron that it needs to lose to fill that outer shell. So what we can do is we can bring in a second bromine. If we do that, that bromine has 7 valence electrons. And it needs an extra one. So magnesium, with its additional electron, can transfer that to bromine. Now what we can look is magnesium now has lost both of its valence electrons, and so it now has a full outer shell. and both bromines now both also have full outer shells. So the first step is done. Second step is we're going to show the elements with their charges. So we're going to put magnesium in the middle with a bracket around it, and magnesium lost 2 electrons, so now it has a positive 2 charge. And on each side, I'm going to do 1 bromine. 1, 2, 3, 4, 5, 6, 7, 8, and that has a 1 minus charge. On this side, I'll do a bromine as well. And we do them on opposite sides because they're both negatively charged. And negatively charged objects want to get as far away from each other as they can, but they're both going to be attracted to the magnesium. So this is also a 1 negative charge. So that's my second step. My third step then would be to write the element formula, or the chemical formula, excuse me, for this, which would be Mg. I always do my metal first, so magnesium is my metal. It goes Mg. I have 1 of them, so just Mg. And then Br. And now I have 2 bromines, obviously 1 here, 1 here. So this is going to be MgBr2. And the name for this would simply be magnesium bromide. So we keep the metal the same name, and all we do is we change the ending of the nonmetal to an ide. So magnesium bromide. The last example we'll do is the elements potassium, so K, right here on my periodic table. First column, 1 valence electron, and oxygen. Oxygen sitting right here on my periodic table. It has 6 valence electrons. 1, 2, 3, 4, and then I can start doubling up. 5, 6. All right. So same thing here. Potassium is going to want to lose its valence electron. Oxygen is going to need to gain an extra electron. So potassium is going to transfer its 1 electron over to oxygen. Potassium's happy. It's lost all of its outer electrons and now has a full shell. Oxygen, though, still needs an extra electron. So what we can do is we can add another potassium. We can't choose a different element. We just have to choose the same element that we started with. So potassium, with that 1 valence electron, is going to transfer it over to oxygen. Both potassiums now have full outer shells, and oxygen now would have a total of 8. 1, 2, 3, 4, 5, 6, and then the single from this potassium and the single from this potassium for a total of 8. What I'll do now is I'll show the charge. Now with this, because I have only 1 oxygen, my oxygen is going to be in the middle. It now has a full outer shell because it gained electrons. So I'll show those electrons, and it now has 2 more electrons than normal. So 2 negative because it gained electrons. On the outside, I'll have potassium. Potassium lost 1 electron, so 1 positive. Now has 1 more proton than it does electron. And on this side, I'll show potassium as well. 1 positive. All right. The chemical formula for this, again, I'm going to do the metal first. So I have to do potassium. It's going to be K. I have 2 of them, so K2, and then 1 oxygen, just like that. And the name for this would simply be potassium oxide. Again, we're just going to change the ending of the nonmetal into ide. So that's just a quick demonstration of how we would show and how we can understand how what are called ionic compounds would form by the forming of a positive and negative ion, and those two joining together.